Okay, so when we're looking to calculate permutations or combinations, you've got to know which formula you're going to use. And we're going to look on our calculator. If we want to use a permutation, there'll be a little P button. So you take the total number of things that you have, then you say P, and then the number that you want. And for a combination, it's the total number you have, then the C, and then what you want. The only difference between them is that for permutations, the order matters. So you're looking for something if it's placed in a row, or if it's on a shelf, or if it's a line of numbers, or a combination in a line. Anything like that, there is an order to it, so we would use a permutation. For anything else, when it's just random groupings, we're going to use a combination. So if we look at some examples, the first one we have, over here I say, how many even numbers between 6,000 and 7,000 can be formed using the digits 1, 2, 3, 6, 7, 9 if no digit is repeated? So I want a series of numbers in a line. So because they're now all lined up in a sequence, that means that there's order to that. And it must be between 6 and 7. So meaning it must start with 6,000. So it's going to start with a 6. But it must be less than 7,000 because it's between those. So it's going to start with 6 but be less than 7. Then there is 2 other places there in that number. But the last digit must be an even number because we want to know how many even numbers we can take. So if I look at the digits I have, 1, 2, 3, 6, 7, 9, no digit is repeated. So I've already used a 6. So the only other even number I have here is 2 because 1, 3, 7, and 9 are all odd. So I've got to have 6 at the start and I have to have 2 at the end. So that means there's only 2 places that are unaccounted for. So out of all my numbers that I have left, I have 1, 2, 3, 4 numbers left. So I'm going to say 4 on my total options. And because I'm using an order in a row, I'm going to say I'm going to pick. So I'm going to use P for permutations. And there's only 2 empty spots. So I'm going to say 4P2. And that, if you type that into your calculator, you're going to get an answer of 12. Because on your calculator, as you can see there, up at the top, there is my little P, and it says NPR, so I've got to type in 4, and then P, and then 2 to get my answer. And there is the C, which would type in exactly the same. So if I look at a different example, I've got a committee of 6 people to be chosen from 9 women and 5 men. We need to find the number of ways in which 6 people can be chosen if there must be more women than men on the committee. So this is just a random group of people. There's no order to it, which means I'm going to use a combination now instead of a permutation. And I need to find the ways in which we get the 6 people, but there's more women than men. So I could have 6 women and 0 men. So I'm saying 6 women and 0 men, which means I need to multiply them. So to find 6 women, I have 9 women in total. So I'm going to say 9. And of those 9 women, I am going to choose 6 of them. And then out of the 5 men, I'm going to choose 0. I could have 5 women and 1 man to make up my 6 people. So out of my 9 women, I could choose 5. And out of my 5 men, I could choose 1. Or I could have 4 women and 2 men. So out of the 9 women, I choose 4. And out of the 5 men, I choose 2. If I have 3 women, that means I have to have 3 men. And therefore, I no longer have more women than men anymore. So these are my only possible options where I could have more women than men. So if you type this into your calculator, you get an answer of 84. If you type that in, you get 630, and then the last one you get 1,260. So I could either have this option for 6 women, or 5 women, or 4 women. So because I'm saying or, remember or means add. So it's either this option, or that option, or that option. So I need to take all of these and I add them together for my final answer, to give me my total of 1974 when I add everything together. So then the next part says, the 9 women and 5 men include a brother and sister. Find the total number of ways in which the committee can be chosen if the sister and the brother cannot be on the committee, both be on the committee. So, because they can't be together, the easiest thing to do is to find where they are together and subtract it from all the total options. So if both are on the committee, it means that the brother and the sister have taken 2 spaces on the committee, and our committee, remember, is made up of 6 people. So they have taken 2 of those 6 places, and because they are both there, they are now taken out of the total that we have left to choose from, because we've already chosen them. So we had 9 women and 5 men. So when you add that together, it means there was 14 people to choose from. But now you've taken the brother and you've taken the sister out. So that means that there is only 12 people left to choose from. And of those 12 people, we only need to choose 4, because the brother and the sister are there taking up 2 of the 6 places. So there's only 4 left. So we only chose 4 of the 12. And when you type that in your calculator, you get an answer. So now, this is when they are on the committee together. So what we need to do is we need to take this away from the total to find when they aren't. So our total, unrestricted, so we don't have to worry about the first question with more men or women. It's just simply choosing 6 people out of the total number I have. So I have 9 women and 5 men. So out of the total, I had 14 people to choose from. And out of those 14 people, I chose 6. So when we type that, we get 3003. So now, when I want the number of ways that we're going to have the committee without the brother and sister together, it means the total minus when they are both there to give me my final answer. Okay. So then another example, I have 3 letters selected from the 9 letters in the word cameraman. We need to find the number of selections if the 3 letters include exactly one M and exactly one A. So I'm only choosing 3 letters, and now it has to have one M, so we have to have the M, and one A. So now it has to have the A. So now I'm only left with space for one more letter. And I'm having exactly one M and exactly one A, meaning all the other M's and A's in there are going to be excluded. So if we look through the rest, my only other options left are the C, the E, the R, and the N that are not the M's and A's. So that means that I only have 4 options left between those other letters, and there's only space for 1. So out of those 4 options, I'm going to choose just one of them. We use our combination because there's no order to that. We're just choosing a group of letters. So 4C1 gives me a total answer of 4. Then we need to find the number of different selections if the 3 letters include at least one M. So because I said at least, it means we could have 1, Or we could have 2, because there could be more, because in there is 2 m's. But there's also multiple a's. So what we need to do is we need to separate them. And first we look at when there's m's, and then we look at when there's a's. So if we look at just when there's m's, so there could be one letter m, meaning there's 2 other spaces. And out of that, now we exclude all the a's because the a's are also repeated. So now we just look at the m's and we want just one of them. And then we look at our other letters without the a's. So there's the C, the E, the R, and the N. Again, there's our 4 letters. So out of our 4 remaining letters, we're only choosing 2 for the remaining spaces. And that will give us an answer. Then I could have 2 m's because I had at least one, so I could have an M and another M, and then my last letter. And again, I'm excluding the a's, so I'm just looking at the remaining other letters. So there's still 4 other letters, but now I'm only choosing one of them because the other 2 spaces were taken up by the m's. So I get an answer. Now, those are the only multiples of m's. So now I can go back and I can start to look at when there's a's as well. So I could have one m, and with that one m, I could also have one a, and then another space. So now when I have the m's and the a's, I still exclude the m's and the a's from my possible options, and I look at all my other letters for that last space. So now there's still going to be 4 other letters, and I'm still only choosing one from that space. Or I could have that one M. With that one M, I could have an A, and I could have another A. Now all the spaces are taken up. So this is just one thing. So I can say this is one option. And the other way, I could have multiple M's. So I could have an M and another M. And it could be with the A. And that, taking up all the letters, is also one option. So now I could have this option, or this one, or this one, or this one, or that one. So because I'm saying or, I'm going to add all of these options together. So I could have 6 plus 4 plus 4 plus 1 plus 1 to get my final option answer for all my options in there. Okay, and if we look at one more example, I am going to have, if I look at just the first one, I have 8 children of different ages stand in a random order in a line, and we need to find the number of different ways that this can be done if none of the 3 youngest children can stand next to each other. So that means the 3 youngest can't be next to each other out of 8 children. So there are 5 children that need to stand in between the 3 younger ones. So I could have the older ones. They could be a young one, an old one, young one, old one, young one, old one, young one, old one, and they space. So there's our 1, 2, 3, 4, 5 older children, and in between each of them there's got to be spaces for the younger ones to stand. So the 5 older children have 5 different places they could stand. So if there's 5 places for the 5 children, that means it's going to be 5 factorial. But then the 3 younger ones, there's only 3, but they could stand in all of these other open spaces. And there's 1, 2, 3, 4, 5, 6 different spaces there. So we're going to have, out of the 6 spaces, because they're in a line, it means there's order to them. So out of the 6 spaces, you're going to pick 3 of them for the children. So we're going to have our 5 older ones and then our 3 younger ones to give us a final answer of 14400. So if we look at the second question in there. So in the second question, we've got David chooses 5 chocolates from 6 different dark chocolates, 4 different white chocolates, and 1 milk chocolate. He must choose at least one of each, and we need to find the different numbers of ways that he can make these selections. So he needs 5 in total, and he must have at least one of each. So he could have dark chocolate, he could have white chocolate, and he could have milk chocolate for all of our options. So now to get 5 in total, so he needs at least one of each, but he could have maybe 2 of those and 2 of those, because now that's 5. So if we look at that, the dark chocolate, he has 6 dark chocolates and he's only choosing 2 of them. And so we multiply. The white chocolate, he has 4 white chocolates and he's only choosing 2. And the milk chocolates, he only has 1 milk chocolate and he's going to then choose that one. So out of those ones, he's choosing 1. So now he must have at least 1 milk chocolate, and there is only 1. Then he could maybe have 1 white chocolate and 3 dark chocolates. So that means out of the 6 dark chocolates, he's going to choose 3. And then out of the white, there's 4 and he's choosing 1. And out of the milk chocolates, there's 1 and he's choosing 1. Or he could have 1 milk and 1 dark chocolate and then 3 white chocolates. So out of the 6 dark chocolates, he's choosing 1. And then out of the 4 white chocolates, he's choosing 3. And out of the 1 milk chocolate, he's choosing 1. Now we can't have any other combinations because there was only 1 milk chocolate. And he has to have at least 1 of each chocolate in there. So these are all our possible options. So if we type those into a calculator, we get 90, 80, and 24. And now he has this option, or this option, or this option. So because I said or, we're going to add them together. So we say 90 plus 80 plus 24 is going to equal 194 different ways. So if we look at the last one, it's very similar to the one we just did. So we now have a password for Chelsea's computer consists of 4 characters in a particular order. The characters are chosen from the following: the 26 capital letters A to Z, the 9 digits 1 to 9, and then 5 different symbols. And the password must include at least 1 capital letter, at least 1 digit, and at least 1 symbol, and no character is repeated. So we need to find the different passwords that she can make. So we've got capital letters, digits, and symbols, and she's got 4 in total, but she must have at least 1 of each of them. So she could have 1 capital letter, 1 digit, but now she needs 4, so that means she could have 2 symbols. Or she could have 1 capital letter, 2 digits, and then 1 symbol, or 2 capital letters, 1 digit, and 1 symbol. So now if we look at our options, capital letters, there are 26 available, and she's going to choose just 1. And her digits, there are 9 available, and she is going to choose just 1. And her symbols, there are 5 available, and she is choosing 2 of them. Then she is going to have one capital letter of 26, choosing 1. The numbers, out of the 9, she is choosing 2. And out of the symbols, there are 5 and she's choosing 1. And then out of the 26 capital letters, she's choosing 2. Out of the 9 digits, she's choosing 1. And out of the 5 symbols, she is choosing 1. But now, because we're dealing with a password, there is an order to those passwords because we didn't say where the capital letter must be, or the digit, or the symbol in those 4 things. So those could be placed in an order of the 4 different things. So for each of these, we need to times it by 4 factorial for the placement of the capital letters, the digits, and the symbols. So we're going to times that by 4 factorial, times that by 4 factorial, and times that by 4 factorial, because remember, each of these is our different options that we're going to have. So if you type that in your calculator, you get 351,000. The next one, we get 112,320. And the last one, we get 56160. And now because I'm saying this, or this, or this, I'm going to add all of those together. So if I say my 351,000 plus 112,320 plus 56160, I'm going to equal 519,480 as my final answer.